Our next session is going to be industrial control systems, discussing solutions. And if we could have Scott Bauer, Dale Peterson, Brian Owen, Leo Frankel, and Walter Sikora join us on the stage. We'll get going with that here momentarily. So joining us today, we have Scott Bauer from the Department of Homeland Security Control System Security Program. He's here in place of Rick Lichtenfels, who was supposed to be here earlier. So Rick was very, very gracious to strongly suggest that we have Scott join us, and we're very pleased to have him. We also have Dale Peterson from Digital Bond, who cut his teeth in the world of security with his work in, among other organizations, work as a cryptanalyst and code breaker with the NSA before moving into the commercial sector where he specializes in control system security. Brian Owen joins us from OSIsoft, where he works diligently in helping develop tools to securely manage industrial control systems. Leo Frankel joins us from Waterfall Security Solutions, which is an organization specializing in providing products to segregate or air gap ICS from less critical operations. And Walter Sikora joins us from Industrial Defender, which is an organization that has literally exploded onto the world of ICS security in the last several years. So I guess I want to start with one of the most interesting developments in the world of ICS has been the public-private partnership. And I want to direct this question to Scott. What are we hoping to accomplish in the world of ICS security as a result of this public-private partnership?
Part of the expectations there has a lot to do with education. I think one of the panelists previously mentioned that at most facilities, most are not capable of defending against an organized type threat. Through education, and it could be some of the CSET assessments that are performed by the Control System Security Program. It could be incident response for ICS CERT. It could be some of the training capabilities that are out there with the public sector. So again, education I think is incredibly important. We have a good turnout for this conference, but again, how many others aren't putting security, cybersecurity forefront in their minds?
Well, great, thank you. I guess, and I'll let everybody speak to this. One of the most challenging issues we are facing with ICS and the smart grid is legacy equipment that was never designed with any cybersecurity whatsoever. It was designed that way. Perhaps the biggest issue we face with this ancient yet fully functional equipment is the fact that retrofitting it with security is extremely challenging at best and impossible at worst. What would you recommend as the best course of action in such situations? And I guess I can start here on this end with you, Brian, and work our way down the panel.
Yeah, thanks, Mike. You know, it's a really interesting question dealing with legacy systems, and I've got a couple points I'd like to raise out, and I'm sure I'll leave a few for fellow panelists. But one of the first things, in my experience, is that a lot of legacy systems, a lot in terms of security, is left on the table. There are features in these control systems that could be used to get a better, I guess, awareness of both integrity of the system and how the system's being used, how its health is at a given point in time. And a lot of times that information is just flat ignored or only used for extreme, dire troubleshooting kind of purposes. So that would be my first point, is to really understand your system, your control system very well, and know what it can do and leverage it. The flip side of that is recognizing that control systems also may have features that are outside of the core, and really only using the features that are needed. For instance, many control systems have reporting packages. You can make a strong case that that's increased surface to try and secure and manage, and quite frankly, there's better solutions out there for reporting. So on one side, know what your system can do and leverage it in a very smart way. Also know what your system can do and don't use those features that really it wasn't designed as a primary functionality. So I'll pass it to you, Leo.
Okay. Thank you, Brian. I think that for legacy systems and as smaller as they go up to the edge systems, it is harder to add security to them. And I think it's better to look straight in the mirror and say, well, we cannot. Okay, we need to buy new ones. But until we do that, I think the only thing that you really can do is to try and shield your back office systems. Okay, your control centers, your central systems from the security risk that can come from these devices, and try to add systems that detect anomalies and detect attacks as they go, and not add security to them, because at the end you'll not be able to do that. It's better just to try and be secure in this time, be more secure in the time between until the system that you have are old enough to be replaced. So try to detect attacks and try to shield yourself from the damage, but adding something on a old meter that has no CPU and you cannot add, it just won't work. At least from our experience, this is what organizations that did really try to add security came up as a solution at the end.
Okay. Scott, do you have anything to add to it? Or?
Sure. I guess a lot what we see with legacy systems, especially when we do incident response or actually go out and support the community, is that a lot of things are inherited based upon when the system was installed. A lot of these could be even simple remote access for a modem bank, or those things are still used. So I think a lot of the systems get stuck in the old paradigms where they don't look at managing the risk. When they were installed and when they were put in, they probably met the risk profile. But as the risks change, the system doesn't change. And so a lot of the inheritance that goes on is sometimes a lot of the problems we see. Good enough before is not good enough now. Dale?
One of the things that's kind of surprising is that a lot of people are looking at meters and other smart grid equipment and find the security lacking, but in many ways it's so far superior to what you're going to see in a distribution or transmission system today, where your field devices, your PLCs, your RTUs have little or no security. They're not authenticating the source, they're not authenticating the data being sent, the commands, the firmware uploads. So basically, if you can get to that device, you can do whatever you want with it. And there have been some big examples of this last year. So I think when we look at the situation with the legacy, we're trying to say, if the smart grid is extending to consumer and businesses, the networks is out there. I know the people in this room and many others are trying to secure all the way to those endpoints, but we're assuming that something that can't be physically protected is going to be compromised. So what we look at in terms of the legacy problem is, how can we limit what those end nodes at a consumer or business can do back to the traditional distribution and transmission system? And Lior kind of touched on this. I mean, that has to do with limiting what data can come back, and that's more than just simple firewalls that are limiting it to IP addresses and ports, but we're talking deep packet inspection of some of these specialized protocols, perhaps one way where it's appropriate, perhaps something we haven't thought of yet. But if we're talking about insecure sites that potentially could be compromised, having some sort of data access back to a legacy system that can't be protected, we really have to find some way to ensure that only legitimate data is coming back, and anything that could cause problems can't get back to those legacy systems.
Yeah, so I think the funny thing is people think newer is better. And if you think of legacy systems, sometimes old is good. And the fact of the matter is it's been there for a long time. It hasn't been compromised, albeit it may not have modern security. The reality is it's been in place, it's been running, and we understand it. Often the modern things that we put in are very complex. We try to make it better. And what we do know is that change equals risk. And sometimes going with the new is not necessarily better. As for securing what's already there, you know, these systems get put in, they're there for a long time, 15, 20 years. And what we'd like to think is that we can make them better. We can secure them. There is technology, whether we limit access to them or secure or make the shell hard around them, that's been proven. There are solutions available to make that happen. But the reality is, I think my position is that, you know, certainly the older legacy systems can be secured, can be made better, and I think sometimes the newer stuff isn't so much the better stuff. I know the vendors, if there are vendors in this room, probably don't want to hear that because it kind of affects their refresh, you know, business. But there's solutions out there to fix that.
Well, so if I could ask you a question then, Walt. So that's an interesting perspective. What is Industrial Defender doing to secure legacy systems, or is that really the area that you're focused on, or is it more just information based, or, you know, specifically, you know, where do you see the opportunities to add that layer of security?
Right. So clearly, our business is securing all types of systems. We're agnostic to the application, the platform, the operating system, the vintage of the control system. And the way we try to design our technology is really to address the market. And the market, again, because of the nature of these systems and the diverse, you know, nature of all the different types of systems we have out there, you have to have technology that's capable of being applied to, for example, you know, I'll take, you know, Windows NT Service Pack 1. There aren't many modern technology vendor solutions that will work on that platform. Microsoft doesn't support that platform. You can't get any, you know, malware prevention for that platform. Yet that platform is used considerably still today. We've got a lot of Pi servers running on Windows NT Service Pack 1 pre-Pentium class machines. What do you do with that? Rip that, throw that away? They still work, and the utilities just don't want to replace that. Now, one thing that's interesting is that one could argue that, you know, these utility engineers that have been trying to preserve this and extend the life of those assets are actually doing a disservice by taking exception and maintaining that equipment and not replacing it with something more modern. But I think deep in their minds, they know it works, they understand it, and their fear is if they replace it with something new, it's just going to become more operational burden for them and probably a higher risk. So Industrial Defender as a company, we focus a lot of our energy on making sure that all of our technology can work all the way back to you know, the basic level that we find out in the field is part of our market. And we have, you know, people that understand that and try to make it work for that.
So sort of, thank you, Walter. So sort of taking sort of like the opposite tack then, Lior. So you're saying you've run across things and say, you know what, it's just better to just air gap it, segregate it, which is very interesting. You have a very unique, simple product, and, you know, the first thing I thought of, and several people, why didn't I think of that? You know, explain why you believe, and you said it very well yesterday, if I could quote you, we can guarantee 100% security 99% of the time, you know, and explain, you know, your approach and what you've taken and to deal with the security issues.
Thank you, Mike. There are scenarios or topologies which are very common in the industrial world, where you have an environment which is self-sustained and self-operated, and does not need any control or any command to get in from external environments. Yet, this environment needs to update the external world on what's going on. What's going on inside, alerts, alarms, if it's a power plant, production rates and so on. And to connect in a bidirectional medium, this network with an external network, by definition, risks the industrial network. Okay, something can come in. It does not matter how well your security is. All software-based security or logic-based security can be hacked and can be circumvented. It's it's a fact. It's by design. The medium is bidirectional, so something can penetrate from outside. And in this situation where you only need to update outside, you do not need to take the risk. When you have to take the risk, take it. Take it, put whatever security you can, monitor it, audit it, and do whatever you need to do to reduce the risk and reduce the damage. But in this situation where you just don't take the risk. Put your resources in, save your resources to protect other places. And this is what we do, and I'm happy to say that more and more utilities and critical infrastructures here in the States are deploying our systems. We started with mainly with the nuclear power plants back 3 years ago here, and today we are in many other types of utilities, including water facilities and oil and gas facilities, and starting to get a lot of interest from other types of utilities also. And I have the personal interest in this cell, but it's also good to know that that the total security of the critical infrastructure is better today, much more than 2 years ago.
Well, that's good to know.